Hi students, this is Mr. Yao. Today we're going to talk about 5.6c, where we will learn about triangle midsegments, median, and centroid. So after we talk about triangle proportionality theorem, this lesson is actually the special case of proportionality theorem. So let's have a look. Midsegment. A midsegment of a triangle is a segment that connects the midpoints of two sides of the triangle. And all triangles have three mid-segments. So in this case, you see the midpoints are right here because they were labeled as like a double bar, single bar right here, double bar right here, and triple bar right there. These are all midpoints, which is why MP, MN, MP, they're all mid-segments. Then we have a mid-segment theorem. We're saying if the segment connecting the midpoints of the two sides of the triangle is parallel, so these are midpoints and they're parallel, then that has to be 1/2 of the bottom. And of course, there's also the converse. So the midsegment theorem is a special case of the triangle proportionality theorem and the converse. So now let's have a look at some examples involving midsegments. Example 1. You can see the 5, 6, 6, 7, 7. That means these are all midpoints. And based from that and the theorem, we would know that these lines are parallel. GJ with FK, GJ, FK. Then LJ, FH. Last one, GL, HK. That's example 1. Example 2. Which segment is parallel to GE? GE is right here. You can clearly tell. G is the midpoint of AB. E is the midpoint of CB. So to the opposite of it, that is parallel to AC. Number 3. TUB are midpoints. What are the length of these portions? TU, UB, and QR. First, you do need to identify which one is a parallel to. So TU is parallel to SR right here. So that means TU is 1/2 of SR, which is 20, because SR is 40. Next, UB. UB right here, that's parallel to QS, and that means UB is going to be 1/2 of QS, so 25. Last one, QR. That is parallel to TB, which means TB is 1/2 of QR, which is 30. But I want QR. So QR would have to be 30 times 2, 60. That's example 3. Example 4. This time we have midsegment again because it's indicated with double bar, midpoint, single bar, midpoint, which is why 2x minus 14 over 2x minus 6. That ratio has to be 1/2. And now you're like, wait, like how come? I know the proportionality about the midsegment theorem says is 1/2, but how could I tell here? Well, because if you look at it, triangle HUT is similar to triangle HIG, which means UT over UT right here over IG is going to be the same as HU to HJ. HU is the same as UJ, so that means if this part is 1, then the whole thing is basically 2. That's where we got the 1/2. And UT is 2x minus 14, and IG is 2x minus 6. That's how we got it. Now we just need to solve that by cross multiplication. 4x minus 28 equals 2x minus 6. So 2x equals 18, x equals 9. Actually, not 18. That is 22. 11. That's example 4. Now let's actually look at a proof involving midsegment theorem. First, DE is the midsegment. That is given. But from that, we can conclude the measurement of DE is 1/2 the measurement of BC. So the middle is half the measurement of the bottom, and that is by midsegment theorem. Now we can replace the DE with x, and we can replace BC with 6x minus 1. Don't forget the 1/2 in front of parentheses. And by the way, there was a typo in the question. It should be an x, not 5. So that step I just did is from substitution property. I just replaced DE and BC. Next, solve. And if you see that step, I'm just multiplying both sides by a 2. So I got multiplication property of equality. After that, I'm going to subtract the 6x on both sides. So I got negative 4x equals negative 1. That's by subtraction property. Lastly, I just need to send away negative 4. I'm going to divide both sides by negative 4. I got x equals 1/2. That step is division property of inequality. And that is example 5. Next, we have another definition. We just talked about midsegment, but we also have something involving midpoints, and that's called median. A segment from a vertex to the midpoint of the opposite side. So vertex to the midpoint. These two are being labeled as the same, so that is a midpoint. That thing is called a median. And there are 3 medians inside a triangle. I'm just going to draw it right there. Okay, and then last one around there. The 3 medians of a triangle are concurrent. Concurrent means they go through the same point. Go through the same point. The point of concurrency, called the centroid, is inside a triangle. The point is also called the center of gravity of a triangle because it is the point where a triangle will balance. That's median. Next, concurrency of median theorem. That is saying all the 3 medians actually are going through the same point, but they also form some kind of ratio. The ratio is 2/3. If you have a look at it, AP comparing to the whole thing AE, that is 2/3. And if I want to go further, that means AP is basically, well, not AP, PE is basically 1/3 of AE. Since this is 2/3, the bottom half has to be 1/3. And if you want to go further than that, I can know AP is actually twice. Because AP is 2/3 and P is 1/3. And they all actually have the same kind of relationship. AP is twice. Basically, the longer part of the median is twice of the shorter part. Now let's use that property. Here's the centroid. That means it tells you all these points are midpoints. So we have the 2/3 number that we can use. If SQ, so basically SQ over SW is 2/3. And we know SQ is 8, so 8 over SW is 2/3. Multiply both sides. 2SW is 24. SW is, that's number 1. Number 2. ZA right here is 9. What is the length of ZC? ZA over ZC is 2/3. That's the longer part of the median. So DA is 9 over ZC equals 2/3. Cross multiply. QZC equals 27. So C is 13.5. That's example 2. Example 3. M and K are midpoints, which means this has to be the concurrency. VB is x. BK is -4 plus x. So their relationship again, if this is 2/3, that and this is 1/3, that means VB over BK is actually 2 because that is twice the shorter part. So x over -4 plus x is 2. Let's solve it, or 2 over 1. So now it's time to solve that. We just do a cross multiplication. -8 plus 2x is x. So in this case, x is 8. That's example 3. Example 4. D is the centroid, which tells you G, E, F, they're all midpoints. BD is 4x plus 5. And BF, the whole thing is 9x. So relationship again, BD over BF BF is 2/3. So BD is 4x plus 5, and BF is 9x. Solved by cross multiplication. 12x plus 15 is the same as 18x. X is going to be 5 halves after solving. That's example 4. Lastly, we have another proof. And many of the parts of the proof are given. So this time we're proving concurrency of median theorem. We're actually doing the AF equals 2FE. AF is twice of FE. That's what we're trying to prove. The first step, connect B and E. So connect the midline, the midsegment. Because 2 points make up a line. And then, since the question said triangle ABC has these two as median, that's given, I can say D and E are the midpoints. So D is the midpoint of AC and E is the midpoint of BC. That is if we are given the median definition. Next, because they're midpoints, I can say DE is actually a mid-segment, and that is my mid-segment definition. Next, because that is the mid-segment, we can know they are parallel and also the 1/2. That's what we can get from mid-segment of a triangle. The mid-segment is parallel to the base, and also the mid-segment is 1/2 the length of the base. After that, since they are parallel, these two lines are parallel, I can actually say these two angles are congruent, and also these two angles are congruent. And that's what the next step is. Angle EDF, first one I labeled, is congruent to ABF. ABF right there. Then DEF, that's the level bar, that's congruent to BAF. BAF right there. That is because the two lines are parallel and they are alternate interior angles. Okay, now that you have a look at it, I have two pair of angles that are actually the same. I can clearly conclude by AA similarity that these two triangles are congruent. Are not congruent, are similar. After I confirm the similarity, I can set up some ratios. That means DE right here is, when it's compared with BA, is the same as FE. FE, which is this part that I need, FE right there, when compared to FA, the whole thing. That is 1/2, and that is the definition of similarity. That's how I can get the ratio. Now if you just look at that part, I can just cross multiply, so I can get AF, so 1AF is twice of FE. That is multiplication property of the equality. That is everything for 5.6C. Thank you.